this episode, we're going to treat automation like a helpful robot coworker that can do repetitive cloud tasks fast, but only stays safe if it never gets to keep a permanent master key in its pocket. When people first learn cloud security, they often picture attackers guessing passwords, yet many real problems come from stolen automation credentials that quietly unlock powerful actions. Automation is everywhere now, from scripts that spin up servers to pipelines that deploy applications to background jobs that copy data between storage locations. Because automation runs without a human watching every click, it needs identity, and that identity needs credentials, and those credentials become a high-value target. The goal here is to understand why short-lived access patterns reduce risk, what guardrails keep automation from wandering into dangerous territory, and how to think about these choices in a way that holds up during an exam and in real environments. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful starting point is separating human identity from machine identity, because the security expectations are different even when the cloud platform treats both as accounts. A person can notice something strange, pause, and ask questions, while automation will do exactly what it is told, even if the instruction is risky or the context has changed. That is why we talk about service accounts and application identities, and why those identities should never behave like a shared admin user that everyone relies on. The moment a team puts a long password or a never-expiring key into a script, that secret tends to get copied, backed up, logged, and reused until nobody remembers where it lives. Attackers love that, because it turns one theft into long-term access. Short-lived access is the opposite idea. Credentials should expire quickly, be hard to reuse elsewhere, and be obtained only when needed. So even if something is stolen, it becomes useless soon. To understand short-lived access patterns, it helps to think of credentials like a visitor badge instead of a house key. A house key works every day until you change the locks, but a visitor badge is valid only for a short time and only for specific doors. In cloud environments, this idea often shows up as temporary credentials that are minted for a job, used for minutes or hours, and then naturally expire. Another part of the pattern is that the automation does not store a long-term secret at all, or stores only a very limited secret used to request the temporary one. This reduces the blast radius because an attacker who finds an old token cannot keep using it next week, and an attacker who finds a low-privilege bootstrap secret cannot immediately do everything. The exam tends to reward this kind of thinking because it shows you understand both attacker behavior and defensive design, not just memorized vocabulary. A common beginner misconception is believing that short-lived credentials are only about convenience or only about compliance checkboxes, when they are really about forcing time limits onto trust. If a credential lasts forever, the only time it stops being dangerous is when you discover it was stolen and then revoke it, and discovery can take a long time. If a credential expires quickly, it stops being dangerous even if you never notice it was stolen, which is a powerful safety net. This does not replace monitoring, but it makes monitoring less of a race against time. Another misconception is that short-lived access is too complicated for small teams, when in reality the complexity is often lower than managing scattered secrets across repos, laptops, and build servers. The best design is usually the one that removes secrets from places people forget to secure, and short-lived patterns do that by default. Short-lived access patterns also fit the reality that automation jobs are predictable in time and purpose. A deployment pipeline runs for a short period, performs a known set of actions, and then stops, so it makes sense that its permission should also exist only during that window. A scheduled job that reads logs or rotates backups has a specific schedule, which can map to temporary access that appears at runtime and disappears after. When you build around temporary trust, you naturally start asking better questions, like what exactly does this job need to do? What resources should it touch? And what would happen if it tried to do something else? Those questions lead directly into guardrails, because guardrails are the boundaries that keep automation safe even when something unexpected happens. Guardrails assume mistakes will occur, and they exist to limit the consequences of those mistakes. Guardrails begin with the principle of least privilege, which simply means giving the minimum permissions required to complete a task and nothing more. Beginners sometimes interpret least privilege as making permissions tiny to the point that nothing works, but the real goal is precision, not starvation. If an automation task only needs to read one storage bucket, it should not have permission to read all buckets, and it definitely should not have permission to delete them. If a pipeline needs to deploy an application, it may need to create or update resources in one environment, but it does not need the ability to change identity settings or read unrelated secrets. Least privilege also includes scoping permissions to specific resources, specific actions, and sometimes specific conditions like time, network location, or expected request context. When you apply least privilege carefully, you turn many catastrophic failures into small, contained problems. Another important guardrail is separation of duties, which is about making sure no single automation identity can perform a full chain of high-impact actions by itself. Think about a situation where an attacker steals one pipeline credential and then uses it to both modify code and deploy it directly to production. If you separate roles so that code changes and production deployment require different identities and approvals, then stealing one credential is not enough. This is not about mistrusting people, but about building systems that are resilient when any single component is compromised. The exam often tests this by giving a scenario where one credential does too much, and the best answer is to split responsibilities and limit privileges rather than adding yet another monitoring alert. Guardrails are strongest when they prevent dangerous actions in the first place, not only after damage has started. Short-lived patterns and guardrails work together best when the process of getting temporary access is itself controlled. A good mental model is that automation should have a trusted path to request a temporary identity, and that request should be validated against rules. The validation could include what job is running, where it is running, what environment it is targeting, and whether the request matches an approved workflow. Even without going deep into vendor-specific mechanics, you can understand the security value. The system checks context before issuing power. This reduces the chance that a stolen secret from one place can be replayed from another place, because the context will not match. It also reduces the chance that a developer accidentally runs a production-level workflow from a personal machine, because the trusted path will refuse to issue credentials in the wrong place. That refusal is a guardrail, and guardrails should be allowed to say no. One risk that deserves special attention is secret sprawl, which is what happens when long-lived secrets end up in too many locations. A key might appear in a code repository, a build configuration, a support ticket, a chat message, and a wiki page, all because someone was trying to make something work quickly. Once that happens, rotating the secret becomes painful, which encourages teams to avoid rotation, which increases risk even more. Short-lived access patterns reduce secret sprawl by making the secret less valuable and by reducing the need to copy it around. Still, you often need some bootstrap method to allow a system to request temporary credentials, so guardrails must also include how secrets are stored, who can read them, and how access to secrets is logged. A beginner-friendly way to think about this is that the safest secret is the one you never have to store at all, and the next safest is one that expires quickly and is protected by strong access rules. Rotation is another topic that connects strongly to short-lived access, because rotating a permanent secret is like changing the locks, and you want to do it before an attacker uses a stolen key. With short-lived credentials, rotation becomes less urgent for the temporary tokens because they die on their own, but rotation still matters for any root of trust that can mint those tokens. Guardrails here include automatic rotation schedules, clear ownership of who is responsible for rotation, and testing that confirms rotation will not break critical automation. A common failure pattern is that teams rotate a secret, the automation breaks, and then someone disables security controls to get things running again. A better approach is to treat rotation like a planned exercise, where you have a rollback plan and you confirm that the automation can retrieve new credentials without manual intervention. The security value is not only the act of rotation, but the ability to rotate quickly when you suspect compromise. Another guardrail that is often overlooked by beginners is limiting where automation can run from, because location and environment are part of trust. If an automation job normally runs from a controlled pipeline environment, then a credential should not be usable from a random device on the internet. Constraints like this reduce the usefulness of stolen credentials because the attacker cannot easily match the required environment. This also helps with accident prevention because it discourages running production automation from uncontrolled places. Even if you never name a specific technology, you can understand the concept as binding access to a known execution context. This is especially important for credentials that can affect identity, keys, networking, or data storage, because those areas can create long-term damage if changed. Guardrails that restrict execution context are like putting a sensitive machine in a locked room instead of leaving it in the hallway. Monitoring is not the focus of this episode title, but it still matters as a guardrail because it helps you catch misuse quickly. The key idea is that automation should have predictable behavior, so unusual behavior can be detected more easily than with humans. If a deployment pipeline suddenly starts reading large amounts of data from storage, that is a strong signal that something is wrong. If a scheduled job suddenly starts creating new identities or changing permissions, that is another strong signal. The guardrail mindset says you should define what normal looks like for automation, and then watch for deviations, not just watch for obvious failures. This also connects to short-lived access because the window for misuse is smaller, but that window can still be dangerous if the privileges are too broad. A good design shrinks both the time window and the privilege window. It also helps to talk about failure modes, because beginners often assume security controls only need to work when everything else is working. In reality, automation fails in messy ways, like retries, partial deployments, and timeouts, and attackers can take advantage of that confusion. Guardrails should account for the fact that a job might rerun unexpectedly, might hit an error and fall back to a different path, or might continue operating with stale assumptions. One useful approach is making sure automation identities are tightly tied to specific tasks and environments, so a retry does not turn into a privilege expansion. Another is ensuring that a failure does not cause the system to switch to a more powerful credential as a convenience. When systems fail open, they become easier to keep running but much easier to compromise, and the exam often nudges you toward designs that fail safe instead. A realistic example can make these ideas stick without turning into a step-by-step lab. Imagine a nightly job that gathers inventory data about cloud resources for reporting. If it uses a long-lived key stored in a script on a server, an attacker who finds that key can quietly query the environment every day and learn what to target. If instead the job requests a temporary credential only at runtime, uses it only for read-only inventory actions, and then loses access automatically, the attacker's opportunity shrinks dramatically. Add guardrails like restricting the job to run only from the scheduled system, logging every inventory request, and preventing it from reading unrelated secrets, and you have layered protection. The goal is not perfection, but making compromise harder, making damage smaller, and making unusual behavior easier to spot. That layered approach is what security design looks like in practice. Another example is a deployment pipeline that pushes application changes. If the pipeline identity can both read sensitive data and change identity settings, then compromising it could allow an attacker to steal data and then cover their tracks by changing permissions. Guardrails would split those responsibilities so the pipeline can deploy application resources but cannot alter core identity controls or key management. Short-lived access would ensure that even if a token is captured, it expires quickly and the attacker cannot keep returning with the same access. You might also add guardrails like requiring a separate approval step for high-risk environments or limiting deployments to specific branches or release processes. Even without describing a specific product, the design pattern is clear. The pipeline gets only what it needs, only when it needs it, and the system refuses risky actions outside approved pathways. When you bring all of this together, the big picture is that automation is powerful, but power must be wrapped in boundaries that are stronger than good intentions. Short-lived access patterns are about time-bounding trust, so stolen credentials naturally lose value. And guardrails are about scope-bounding trust, so even valid credentials cannot do everything. The best designs use both, because a short time window is not enough if the credential can still delete everything in that window, and narrow permissions are not enough if the credential lasts forever. For exam thinking, It helps to remember that credential protection is not only secrecy, but also how long the credential remains valid, where it can be used from, what it can do, and how quickly you can cut it off. In real environments, these same ideas keep routine automation from becoming the easiest doorway for attackers. If you keep that mindset, you will naturally choose designs that are safer, easier to manage, and more defensible when someone asks you to explain why the controls work.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.